All right. Now, chapter 1 review. All right. Again, we have a test on Monday. All right. Chapter 1 should be super duper easy for the most part. A few things are difficult, but for now, we're just going to run through this and do as much as we can. All right. Number 1, questions 1 through 3. Here we go. What is another name for line L? Now, when you name a line, you can do it with italicized letters, but no one really writes in italics anymore. So we usually name it with 2 points. So another name for line L could be RU. Thank you, whoever said that. RU. And then, of course, you have to draw the line above it. All right. Instead of calling it RU, you could also call it RS. And instead of calling it RS, you could also call it what? SU. Those are your choices. All right. Now, could you also call it UR or SR or US? And the answer is, of course, what? Yes, you can. All right. Now, that's a good question. Somebody said, what about RSU? RSU is okay, but we only name a line with what? 2 points, not 3. All right, we name a line with 2 points, not 3. All right, so now, question number 2. Name the intersections of line L and line M. That would be a what? That would be a point. So what point? Right. And there is no fancy symbol for point S. All right. Now, someone's got to remind me, what does collinear mean? From all the studying that you did over the summer, you should know what collinear means. Anybody know what collinear is? Say it again. Somebody said something. You said I said, what are collinear? And you said They're like touching. Say it again. Go. One's on the outside. Say it again. Actually, collinear just means points that are on the same line. All right? Perfect. All right? Points that are on the same line. So here, naming 3 collinear points, you could say points R, S, and U, or you could say V, S, and T. V, S, and T. Anybody have any questions with that? Now, this is going to be dumb, but I'm going to ask it anyway. R, S, T, are they collinear? No, they are not on the same line. All right? So if collinear means points that are on the same line, what do you think coplanar means? That was a bunch of mumbling. Thank you. I knew I could count on you, Sam. Points on the same plane. That is exactly right. So coplanar, all right? Points that are on the same plane. So tell me something about this figure up here. What points are in the same plane? Say it. R, T, V, U. What about poor S? S is not in the same plane. How is S not in the same plane? No. No. Here we go. Let's talk. Let me show you something. Let me show you something. Again, I kind of see the biggest problem I have is geometry, for the most part, is a lot of visual. All right. And that's why some kids have a harder time with it. All right. There's a lot of visual. Right. And you just have to try to do better at that. All right. You have to see things better. And sometimes seeing in 3D is very difficult for people. All right. So what I want to do right now is I want to tell you something that's important, that's on a lot of tests, is that you have to know that any 2 points determine a line. All right, any 2 points determine a line. All right, now the important one that I need you to understand, any three non-collinear points determine a plane. Any three non-collinear points determine a plane. All right? So if I have these 3 points, I'm just going to draw 3 points right here. Those 3 points are exactly on how many planes? They're on one plane. That is correct. All right? Now, if I say this, these 3 new points right there, those 3 points I tried to draw so they looked on the same line. Do those 3 points make a plane? No, they don't. And I'm going to show you why in a minute. All right, I'm going to show you why in a minute. All right. But that's something that is really important. Now, the other thing I want you to add to a little note on your iPad here is there are 3 terms in geometry that are undefined that we use all the time. All right? And they're like the foundation of all of geometry. And I always remember arguing with my math teacher about how silly that sounded when you are telling me that the foundation of geometry is based on 3 terms that you can't even define. All right, and the 3 terms that you can't define, believe it or not, are a point, a line, and a plane. So people can't even tell you exactly what a point means. People can't really tell you what a line means, and people don't really have an understanding of what a plane is. All right, to me, it's all like a visual thing. All right, a point just represents a location. Does everybody agree with that? All right, but now keep in mind, what I'm going to do is I'm going to draw a point and then kind of show you something. There's a point right there. Does everybody see that? Yeah. All right, now, the reason why I tell kids it's not defined is because if I continue to blow that point up, it might start to look like a plane, right? Or if I make it what? Smaller and smaller and smaller and smaller, it becomes what? A smaller point. Does everybody understand what I'm trying to get at there, right? There's no definition of a point. All right, as hard as we try, we can't define it. All right, and then after we do point, we come to something called a line. All right, and then I try to describe why there's no definition of a line. One is it's just goes on to infinity, to the right, to the left. Does everybody agree with me on that? Yeah. But then I try to show kids that the reason why we say there is no, because it could get smaller and smaller and thinner, right? Does everybody understand what I'm saying on that? All right, so we have like a visual of what a line is, but there really is no clear definition of what a line is. All right. And then the last one, point, line, and what? Plane. All right, so the wall in front of you, right, looks like a plane. The plastic glass in front of you looks like a plane. All right, but a plane extends indefinitely in all directions. And then I talk to kids generally about, well, how thick is it? Or how thin is it? Right, and then we get to this, like if we were walking, is it possible to walk on a straight line, in a straight line? Right, most people say, yes, it's possible, but we're on a what? We're on a ball, so if we're on a ball, we're not really walking in a straight line. Does everybody agree with that? All right, so it's just your perspective. All right, we look really big, right? But in the grand scheme of things, we are actually what? Very, very what? Small. All right. So again, it's just your perspective. All right. That's why I personally think geometry is harder than usual. All right. And I can remember arguing with my geometry teacher all the time. We're simply stating the obvious. All right. I can't define what a point, a line, and a plane is, but yet it's used throughout geometry, and we're going to use those terms to define other terms. So to me, geometry was a kind of a contradiction. All right, I enjoyed geometry, but not as much as I enjoy the algebra classes in the Algebra 2. So again, geometry is really peculiar, and there's more knowledge in here where you just have to know certain things. You can't really figure things out, you just have to know it. All right, so again, point of emphasis today, point, line, plane are the 3 undefined terms they'll be asking you about. All right. Now, what I want to do now is I kind of want to look specifically at number 4. All right, question number 4, I would want someone to tell me how many planes are there. How many planes do you think? 3? How many planes? 3. Wow, 8. 8? Yeah, right. So again, and this is something you're just going to have to get used to. There are 8 planes here, even though we don't know what a plane is, right? It's kind of like a wall, right? So how many walls are on this hexagonal prism? That is exactly right. So what are you thinking? You only see 3? Right, exactly correct. So I understand now, you guys who said 3. I totally understand that. All right, maybe I should rewrite that. All right, how many planes are there in the figure? Maybe that's a better way to say that. All right, so these you guys who said 3, but does everybody understand the answer that I wanted was 8? Does everybody agree with that? All right, I don't think that's hard. Now, here is something I want to put up on the board, and I want you to tell me if you are agreeing with me. All right, so please look up. You can just kind of pay attention here. If I say this is A and this is B, and I'm just going to label this down here C, I'm going to label this D. All right. Now, I want to ask you this question. Please listen now. This is important. All right. And I'm going to put this up here as E. All right. Is AB collinear?
Yes.
Yeah, AB is collinear. All right, now watch this. Here's where everybody makes a mistake on the test. I'm giving you the answers right now. Is AD collinear?
Yeah.
Why? Because no is wrong. All right. Why is AD collinear? Why are AD collinear? It's not. What do you think? Well, what is the rule? What did I tell you about being collinear? Any 2 points determine a line. Right? So just because it's not drawn, does that mean it doesn't exist? That's difficult for people. Right? So most people on the test say AD is not collinear. But AD what? Is collinear, because if you wanted to, you could draw AD in there, which is kind of annoying. That's how you get tricked. So you got to pay attention now. All right, is everybody with me on that? So is AC collinear? Yes. As long as I say what? 2 points, they are automatically what? They're automatically collinear. Is ABE collinear? No, they're not. Are AB and E coplanar? Yes. Right? Any 3 non-collinear points are coplanar. So, are what? No, they're not. You see why? Because look. Uh-oh. AB, that's a very good question. It almost looks like it, but AB is in the top plane and BC is the side wall. Do you see that? All right, that's what I'm saying. You got to ask me questions now. Is A, B, C, D coplanar? Definitely not. Right? A, B, C, D is not coplanar. Because if I say B, C, D, does everybody see that's kind of like the red plane? And A is not in the red plane. Does everybody agree with that? All right, so again, you got to pay attention. Be real careful. Go.
So if AC could connect, how come it could connect?
Okay, that's a good question because that's not what our question was. So watch what our question was. Our question was A, B, C. Are they collinear? You with me? AC is collinear, AB is collinear, but ABC is not collinear. All right, and now you guys, come on, I'm expecting a lot. So if it's not clear now, it's not going to be clear on Monday. Go.
So ABC is not
ABC is coplanar. They're three non-collinear points. They're on the same plane. You agree? What about A, E, D? Are they coplanar? Yes. The plane is just not drawn. Right? I can draw a plane. I'm going to try to draw it so you can see what I mean. If I draw from A to E, and then I go down here, and then I go from here to here, and here to here. Do you see the plane now, guys? Right, it's tricky. I'm not arguing with you. That's very tricky. So that's why you're supposed to be practicing now. Go. Well, because he is 100% correct. Right, so let me explain this to you. That's a good question. So let me erase this real quick and show you something. All right, even though I'm going to erase all that. So when I said here and I go down here, do you understand that that right here is talking about that wall back there, right? Can you see that or not? You see what I'm saying, right? Now, some of you, I can tell, you're blank staring at me, which means you don't really know what I'm saying. All right, so you got to speak up. Do you understand that's talking about that wall right there, right? Yeah. So there's no way D is on that wall. You agree? Yeah. Just like if I identify this, just like if I set up here, guys, if I'm identifying the top, well, that was kind of bad. If I'm identifying that top right there, do you agree with me? Then D is not in that plane, no matter how hard I try, correct? Yeah. All right, so everybody needs to make sure you hear me. Two non-collinear points, or 2 points determine a line, 3 non-collinear points determine a plane. Now, why is that? I'm going to say one more thing I'm going to ask you. I'm going to let you talk. So what I'm going to do now is I'm going to erase this real quick, and I'm going to ask you something so you can understand. If I put a point here, a point here, and a point here, does that make a plane? No, it does not make a plane. Right? Because I could be talking about the wall over on this side. I could be talking about the wall on this side. I could be talking about the wall going all the way through here. Does everybody see there? All right, hopefully you understand that. So those are the rules. 2 points determine a line. 3 non-collinear points determine a plane. Go.
So you know how you said that A, B, C, D could be one?
Right.
Oh, wait.
You see it now? Yeah. All right, does anybody else have any questions with that? Anybody else? That's good information. Tricky. All right? All right.
Mr. Chow.
Yes, don't be afraid to jump in, guys.
I don't really want to like overthink it though in a test where I'm like, there might be like a plane there though. You know, so is it like?
So the rule is this: if you have 3 points that are not on the same line, it automatically makes a plane. You with me? Any 2 points determine a line. 3 points can be on the same line, but they don't have to be. All right? You guys okay? All right. So let's get started with number 5. What time do I say we leave? 37, right? Yeah, so I just got to make sure I got to pack up early and run. All right, so here we go. So we still got good time. So let's look at number 5. Let's see what this means now. The length of UW, or find the length of UW if W is between U and V. All right. Oh my goodness. So here we go. So what I want everybody to do is draw a line or a line segment. And we want W is between U and V. So I'm going to put U down, and then I'm going to put V down, and then I'm going to put W. And then it says what? UV. Now here's how I want you to write that. This is how I see it better. Uh-oh. To me, that's showing me that the whole thing is 16.8. And then VW is 7.9. So obviously I'm looking for this, and it doesn't take a rocket scientist to tell me how do I figure out what that is. Subtract. So we're going to go 16.8 minus 7.9, and because we are all brilliant, what is it? 8.9, and of course we'd write down centimeters. All right? Anybody have any questions? Anybody have any questions? And remember what I said, guys. It's hard to read your faces because I can't see them really. So if you don't know something, you might as well speak up. All right? It's brand new for everybody. Yes, ma'am. Well, because if I just do 16.8 right like that, I don't know what 16.8 is referring to. You see what I'm saying? So I just try to show you how in my mind I'm looking at it so I know what the 16.8 is referencing. You with me on that? All right. Everybody good? Now, the other thing I want everybody to write down is this. Segment addition postulate. All right, the segment addition postulate. Now, believe it or not, a postulate is something that you have to accept as true, that's based off observation. You are supposed to understand that UW plus WV is equal to UV. Does everybody see that? Now, did I need someone to tell me that? No. To me, that is stating the obvious. Does everybody agree with that? So again, I need you to know the definition of postulate. It's also sometimes called an axiom. All right, some of your old school math teachers will call them axioms. All right, these are things that cannot be proven. Believe it or not, there is no way to prove that, no matter how hard you try. All right, that is something that is accepted as true based off of observation. All right, so that is called the segment addition postulate. All right, and we will be learning how to write proofs in here, which is a whole lot of fun. All right, that's one of the most important things, segment addition postulate. All right, so let's move on. All right, find the value of x if RS is 24 centimeters. So again, we're going to use the segment addition postulate. How do I write the equation? Someone, tell me the equation for number 6. Yes, ma'am. Oh, that's okay to do that, but I'd rather just write the whole equation. Tell me. Yes, and of course, Kenzie, you know you're not wrong. Right, but that's kind of what they wanted. And you know me, I don't care. I just want the answer, right? So some of you guys can just look at that and tell me what the answer is. I'm totally fine with that. So does x equals 3?
Yeah.
Right. So Simon, in this class, I know in your math class probably last year, show all your steps, blah, blah, blah. This is mental math for us. You with me on that? So again, when it's more challenging, you have to show the work. But right now, everyone in here can solve that and just put x equals 3. You with me? All right, if you need to show the work, I'm totally fine with that also. It doesn't matter. All right, now we have to make sure that we answer the question, though. It says, find the value of what? X. So are we done? Yes. But on the test, it might say, what's the value of RT? Right? Then you just got to make sure you answer the right question. All right, that's all I'm asking. Be careful. All right? So here we go. Find the length of LO if M is between L and O. All right, so I just like to draw it out so I don't make a mistake. So M is between L and O, LO, and put M somewhere. And then LM is 7x minus 9, MO is 14, and then LO is 10x minus 7. Tell me.
7x
You are amazing. All right, so now let's do our mental math. Is that right? Anybody else get that? What does x equal? Right? Everybody understands that, right? So if x equals 4, is that the answer this time? Is that the answer this time? I don't think so, because they're asking for what? They're asking for what LO is. And LO is this right here, right? So we would say LO is equal to, what is it? 33. LO is equal to 33. All right. We got time for another one here real quick. All right. So here, what's this symbol mean? Who can tell me? Actually, it's called congruent. Let's make sure everybody knows that. It's congruent. All right. Now listen to me. This is kind of like small, but some math teachers are, detail oriented. So shapes are congruent. Measures are equal, right? So if you're saying one side is congruent to another side, you don't say one side is equal to another side. Does that make sense? Right? If we're talking about numbers, x is equal to 3. X is not congruent to 3. All right, does everybody hear that? All right. In the grand scheme of things, do I really care if you accidentally write congruent or equal? I don't really care. All right. But I need you to know that. Congruent is when you're talking about shapes. Equal is when you're talking about quantities. All right. So now we know that they are congruent. That's what that symbol is. So if they are congruent, then what is the equation? Let's go. Tell me. 9x minus 7 equals 29. I'm pretty happy with that. All right. And so we just say x equals what? 4. X equals 4. All right. Which of the following is not an undefined term? Bisector. Bisector, believe it or not, is I can define bisect. All right. But we cannot define points, lines, and planes. All right. Now listen, guys. For whatever reason, the meeting, I started it. It's like more than 45 minutes, and it's going to shut down here in a few minutes. All right. So what I want to do is I want everybody to, let's go up to question number 24 for homework. All right. Everybody try up to 24 for homework. All right. Does that make sense, guys? All right. So I'm going to say goodbye to all of my homeschoolers. All right. Wish you guys were here. Just get 1 through 24 done, and then we're going to just continue from tomorrow, okay? And I think the link now is going to be good for tomorrow. This was just for today, okay? All right, guys. Have a good day. All right, so I got to stop.